This video is for Math 0232-1332. We're going to be doing the last two new assignments, section 11.3 and 11.4, and that's the end of learning new material. 11.3 is measures of average, 11.4 is measures of variation. Average is the center of data, and variation is how does the data spread out. And then there's just the review for the fourth test, take the fourth test, review for the final, and the final itself. So last two new sections of learning something. Let's start with 11.3. Before we do this, let me write out, okay, the center of data. You go collect data and you have all these numbers written down. The center is talking about the average. Average and center are synonymous. Normally people, when they say average, they refer to one specific measure, but all of these that we're about to learn are considered averages. The mean is the one that most people think of as an average. The mean is when you sum up all your numbers and divide by how many there are. If I take 4 tests in this class and then add my 4 tests and divide by 4, that's the mean. The median is the value after you arrange them in order from lowest to highest. It's the value that's in the middle. The one sitting in the middle after they're in order is considered typical of others. A lot of measurements, you get a lot of answers that are close to the middle, and then there's some unique, really low and high ones. And then there's the mode. This is the one that occurs most frequently, which one happens the most. These are 3 very common measures of center or average, mean, median, and mode. In fact, they're taught as low as junior high when students first see this. And number 1 here says to find the blank, find the value that occurs the most often. So most often, that's the mode. And there is a 4th one called mid-range. I wasn't sure if they were going to do that one here. Mid-range, you don't see this one in junior high, but mid-range you average the highest and lowest number. So it's the max plus the min, and when you're adding 2 things, the order doesn't matter, so you could actually do min plus max if you'd rather do that. Max plus min divided by 2. If you average the highest and lowest, you get something called the mid-range. It's not used as often as the other 3, but apparently they're going to do it since it was an option here. To find the blank, add the values of the data and divide by the total number of values. That's the mean. Okay, see part 1 of 4, I'm guessing they're going to go through the mean, the median, the mode, and the mid-range here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 numbers here. It even says for the 11 largest universities. So if you just simply add them up and divide by 11, people have been doing means since junior high, and we're all familiar with this, and a lot of things in life do this. Schools use means for averaging grades. In sports, they do it often like the players' batting average or their scoring average if they're playing basketball. So you add them all up, and in this case we're going to divide by 11 because there's 11 numbers here. Add them up, divide by 11. Now if it's a long decimal like that, then they should tell me where to round this to. Round to 1 decimal place. 11.3, but there's a 6 after that, so make it 11.4. Okay, there's 11 numbers here. Now the median is not the one sitting in the middle at first. Sometimes students are given a data set like 10, 3, 1, 7, 5, like that. And you ask them, what's the median? And they say, oh, I see a 1 sitting here in the middle. there's two numbers smaller than 1 and two numbers bigger than 1, and they think the answer is 1, and they get it wrong because that's not the median. That's not the one in the middle, actually. You have to put the numbers in order first. 1, 3, 5, 7, and 10. 5's the median because there literally is two numbers smaller than 5, and there's two numbers bigger than 5. So it's not the one sitting in the middle in the original data. You have to sort them from lowest to highest first. And there's 1, 2, 3, 4 9s and nothing else. It's a single digit number. So we have 4 9s. Then there's a 110 and 111. Then there's a 12 and a 13. 6. Did I miss one somewhere? 999. 10, 11. 15, 14, 14, 12, 13. Okay, so 12 and 13. There's a couple of 14s and a 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, good. So once they're in order, if you start checking off the highest and lowest, you eliminate those basically, then eliminate the next highest and lowest, and keep doing that over and over and over again until there's only one number in the middle. There it is right there, 11. So the median is 11 because there's 5 numbers smaller than 11 and there's 5 numbers bigger than 11. Okay, they jump to mid-range next. Normally they ask for the mode next, but the mid-range is often abbreviated MR. It's the lowest plus the highest, or the other way around, the order doesn't matter. Lowest plus highest divided by 2. 24 divided by 2 is 12. Now in some data sets, if you find all 4 of these values, they can all be very similar, like what's happened so far, 11.4, 11, 12, sometimes they're all identical. Other times they're completely different from each other. You just don't know until you calculate them. Okay, find the mode or modes. Let me go through this. For the mode, if you have one of every number or even the same amount of every number, say you had 5 of every number, then there's no mode. One number, at least one number, has to happen more than others for you to have a mode. If they all occur equally, there's no mode. The most common example of that is when they all happen once. It's very common that a data set doesn't have any repeats. So if they all occur equally, no mode. If one number happens twice and the rest only happen once, then that's clearly the mode. 1 would be the mode here because it's happening twice. But there can be more than one mode. You can have 2 1s, 2 2s, a 3, 4, and a 5. And then it's both 1 and 2. So notice the question says find the mode or modes, plural. They don't want to give away if it's just 1 or more than 1. So you can have a tie for the most. Now here's the one that many students get wrong. Say there were 3 1s and only 2 2s, and then everything else happened once. So then students will doubt themselves and they'll wonder, is it only 1 or is it 1 and 2? There's a misconception that the mode is every number that repeats, and that's not necessarily true. In this case, the mode is only 1 because 1 happens 3 times and 2 only happens twice. And it's the one that occurs most. It's not repeats, it's the most. And often it turns out to be all the repeats because often there isn't multiple repeats, or if there are, sometimes there's a tie. But it's not necessarily all the repeats. So here's an example where it's not all the repeats. So just keep that in mind. Whoops, okay, let's go back to our data. See, there were 4 9s and there were 2 14s, so it's not both of those. It could have been both, but it's not. It's only 9. If I get rid of 2 of the 9s or add 2 more four teens, then it could have been a tie, but it's not a tie in this case. Okay, just a second example of this. I think I know where they're going here. 2, 4, 6, 8, 10. See, there's only 10 numbers this time. So add them up and divide by 10. See how when you get data given to you, or if you go collect your own data, it's often mixed up like this. They're just kind of getting random numbers, and sometimes they get higher, and then the next one goes way down, and then it back up again. So you can never get conclusions or information from raw data. It's always mixed up and messy to deal with. But if I add this up and divide by 10, then I get the mean to be exactly 60.3. Dividing by 10 is always nice because it just moves the decimal one spot to the left. Okay, now here's the interesting one. First, I got to put these in order. So there's nothing single digit. There's nothing in the teens. We have a 22 and a 29. 22 and 29 are in the 20s. Okay, 30s, there's a 35, and anything in the 40s, 43. 35 and 43. Anything in the 50s? Nope. 63. And there's two different 74s. That's 2, 4, 6, 7. There's three more. 80, there's this 94, 88, and 81. So 81, 88, and 94. So there's all 10 of them in order. So if you want the median, you start eliminating the highest and lowest, and then go do it again, get rid of the next highest and lowest. Keep going until there's only one in the middle, but sometimes there's two in the middle. If you have an odd number of data points, like last time we had 11 numbers, then there's one in the middle. But if there's an even amount, then there'll be two in the middle. Whenever it's two in the middle, the median is found by averaging those two. In fact, this is like what you do to find a mid-range, except for a mid-range, you do it on the highest and lowest numbers overall. For the median, you do it for the two numbers in the middle. Add them up and divide by 2 whenever there's two of them. You're averaging these two in the middle. 63 plus 74 and divide by 2 is 68.5. And in fact, I'm guessing part 3 is going to be the same thing it was in the previous problem. So mid-range is going to be the average of the lowest and highest numbers. So you find both the mid-range and the median the same way if there's two numbers in the middle. The median's easier if there's just one number in the middle. Then you just write that one down. But mid-range, you're always adding two things and dividing by 2. I've never seen a book do the order of these answers this way, but I just thought, I think I know why they're doing the mid-range third. Usually that's the last one. Most textbooks do mean, median, mode, and because everybody's seen those three before, and then they do mid-range last. Here they did the mean first, then the median is 68.5. And the mid-range, see, they keep doing the mid-range third. Normally that's the last one. But I think the reason why is this right here. Maybe this will help you remember it better. The mid-range is found the same way the median's found whenever there's two in the middle. A lot of students get mid-range wrong because they can't remember it. They never heard of it before. And we're going to do something else called range that'll get you confused about which range are they talking about. So 58. So maybe that helps to do this third. So you can see how it's very similar to the median. And finally, the mode Is there any repeats here? There's two 74s. You have to have at least one repeat, otherwise there's no mode. And when there's no mode, you either say no mode or none. Here they say none. Select none. You just click this none if there wasn't any. But we did have one 74. Okay, so this is, okay, top 10 countries. So there's 10 here. Now these are starting to get to be difficult numbers to work with though. The mean isn't an issue. Just take out a calculator, add them all up, and divide by how many there are. Although it does take a while to type these because they're all numbers in the thousands. See if I can see the other numbers this way. There they are. 2775, 2571, 2385, 2203, and 2091. So I added them up and they add up to this, and then the mean's going to literally be 2856.6 because when there is no decimals in the back, and when you divide by 10 you just move the decimal one place over, but you can literally divide by 10 if you don't know that. 2856.6. So the mean is easy if you have a calculator. You just add them up and divide by how many there are. Unfortunately, the median's going to take a while. Okay, although at least it's somewhat, it's kind of like almost backwards in order. In fact, it is exactly backwards in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So luckily they sort of put this in order for us, because it would have taken a while to take a mixed up version of this and put it in order. So eliminate the lowest and the highest, then the next lowest and highest, then the next lowest and highest, next lowest and highest. There's two numbers in the middle, this 2775 and this 2865. 2775 and 2865. I have to add them up and divide by 2 since there's two numbers in the middle. And it came out to 2820 exactly. Okay, mid-range, take the lowest plus the highest and divide by 2. And the lowest is the last number, the highest is the first number. So 4383 plus 2091 divided by 2 is 3237. And maybe there's no mode here because these numbers are so big, it's unlikely any of them repeated. And putting them in order helps to see there's no repeats. No repeats, so there's no mode. So generally, if you collect real data, this is the average number of cigarettes smoked in these countries. So thousands of cigarettes are getting smoked per person in a year. And that when the data is really large like this, into the thousands, then it gets really hard to deal with it, to put it in order or even calculate some things. But luckily they put that kind of backwards in order to make it a little bit easier. Here's one with only 5 numbers. So add them up and divide by 5. 338 plus 85 plus 123 plus 266 plus 156 equals, and then divide by 5. The mean is 193.6. Okay, since there's only 5 numbers here, there's exactly one in the middle. Get rid of the 2 lowest numbers. The 2 lowest are 85 and 123. The 2 highest are the 300 and the 200 number. So the one exactly in the middle is 156. So that one's easy enough. I probably don't have to write it down. There's 2 numbers smaller than 156, 85 and 123. There's 2 numbers bigger than 156, 266 and 338. So 156 is the one exactly in the middle. Mid-range is always adding 2 numbers and dividing by 2, so you have to add the lowest number, 85, plus the highest number, 338, and divide by 2. The mid-range is 211.5. And then the mode, there is no repeats here. Every number is different. 80, 120, 150, 260, 330. There's 5 different numbers. So no mode again. Okay, the next thing that happens is they put, instead of listing every single data point, sometimes there's just too many data to list them all individually. So then they create this frequency distribution where you have intervals. I think we had this earlier in chapter 11 when we were dealing with making the charts. But now somebody's made the chart for me, and there's 5 numbers between 8 and 12, but I don't know, are they all 8s? Are they all 12s? Are they 8, 9, 10, 11, 12? Maybe they're all different. Maybe there's some repeats. There's no way to know which one it is. And then the same thing here, there's 4 numbers between 13 and 17. There's 11 numbers between 23 and 27. So when we don't know what the individual numbers are, the best we can do is assume they're all the middle. And they're probably not all the middle, but on average, that's what they would be close to at least. So what's the halfway point between 8 and 12? To do what's called the midpoint, you add up the lower number of the interval plus the higher number and divide by 2, just like when you're doing a mid-range. Or think of it this way, what's halfway between 8 and 12? Halfway between 8 and 12 is 10. So since we don't know, are they 8, 9, 10, 11, or 12, then we just assume they're all 10. So all 5 of those numbers we're going to assume are 10. Then we'll do 4 numbers that are halfway between 13 and 17, which if you don't know what that is, add 13 plus 17 divided by 2. Halfway between 13 and 17 is 15. So these are called midpoints. It's technically like the mid-range, but these are called midpoints. And these are frequencies. The frequencies are given to me, so I'm just rewriting them. So the next 2 frequencies are 11. Halfway between 18 and 22 is 20. Halfway between 23 and 27 is 25. Halfway between 28 and 32 is 30. Halfway between 33 and 37 is 35. So if all 4 of these numbers down here are 35s, well, if you had 4 35s, you would add 35 plus 35 plus 35 plus 35. And they're probably not all 35s, but even if I knew what they were, they would be, the sum of the 4 of them would be pretty close to 140. So the quicker way to do it is instead of adding 35 4 times, you can just do 35 times 4. So the next step is to get what's called products. Multiply straight across. 10 times 5 is 50. We just saw 35 times 4 was 140. 30 times 5 is 150. 15 times 4 is 60. 20 times 11, you can just type in a calculator, but if you do 2 times 11, 22, and add a 0 to it, that's the same thing. 20 times 11 is 220. And 25 times 11 is 275. If I add up all the products, what that amounts to is, if I knew every single number and added them all up, that's what it would add to. At least it would be close in this case because we don't know these exactly. But if I take 50 plus 60 plus 220 plus 275 plus 150 plus 140, the total of every number would be something close to 895. And how many numbers are here? That's what frequency is all about. So now you add all the frequencies. 5 plus 4 plus 11 plus 11 plus 5 plus 4. There were 40 numbers in this data set. So instead of writing all 40 of them down and adding all 40 of them, doing the products in essence amounts to doing that same exact thing. So now the final answer is done the normal way. The average is when you take your sum and divide by the total. Well, the sum here is this 895. That's sort of what all the numbers add up to. And the 40 is how many numbers there were. So this gets a pretty good estimate of the mean. If somebody like knew all the numbers and figured it out the normal way and somebody else only had this chart, it turns out that they're pretty close. They're not always identical, but it's close enough to be a good estimate. 895 divided by 40 is about 22.375. Nearest thousandth is, they want all three of those numbers, 22.375. The first decimal place is called tenths, then hundredths, then thousandths. So there's nothing to round because it's exactly 22.375. So that's how you can find the mean of what's called grouped data. Whenever the data is grouped together in classes, then we can't know them individually. Here's a second example of this. Okay, this one will be a little bit harder because the midpoints won't be as easy. So get the midpoint of every interval, and then frequencies are given to you. And then you're always going to find the product. So the frequencies are given 5, 6, 13. Four, 9, 8. I could even add those up right now and get how many numbers are in my data set. 5 plus 6 plus 13 plus 4 plus 9 plus 8. 45 is what we're going to end up dividing by. So what's halfway between 2.1 and 2.7? That's hard to do in your head. So do 2.1 plus 2.7 equals and divide by 2. The halfway point, the midpoint of 2.1 to 2.7 is 2.4. 2.4 is halfway between 2.1 and 2.7. What's halfway between 2.8 and 3.4? 2.8 plus 3.4 divided by 2. 3.1 is. What's halfway between 3.5 and 4.1? 7.6 divided by 2 is 3.8. 4.2 plus 4.8 divided by 2 is 4.5. Now another thing you can do is, maybe not on this one, but on some problems, this always goes up by the same amount. From 2.4 to 3.1, you're literally adding 0.7, then plus another 0.7, plus another 0.7. So I can tell the next one's going to be 5.2 because that's what 4.5 plus 0.7 is. But you can also do 4.9 plus 5.5 divided by 2. See, 5.2. So if you add 0.7 to that, the next one has to be 5.9. Take 5.6 plus 6.2 and divide by 2, it's 5.9. So they just gave us messier midpoints to work with. That's not so easy to multiply these, but just use a calculator and multiply them. 2.4 times 5. The first product is exactly 12. Luckily, it came out to exactly 12. 3.1 times 6 is 18.6. 3.8 times 13 is 49.4. 4.5 times 4 is 18 exactly. 5.2 times 9 is 46.8. And 5.9 times 8, whoops. Do that again. 5.9 times 8 is 47.2. You always add the products after you get them all. So I'll add them backwards. 47.2 plus 46.8 plus 18 plus 49.4 plus 18.6 plus 12. The sum of the products is exactly 192. So the mean is the 192 divided by the 45. So at least it's the same procedure every time you do one of these. You have to get the midpoint of each interval, multiply that to the frequency, add all the products up, and divide by the total of the frequency. 192 divided by 45 is 4.2. Well, maybe they want 4.3 or 4.26. Round to 1 decimal, so 4.3. And notice 4.3 is kind of in the middle of the data set too. If we went back to the previous one, the answer was about 22.3, and 22 is kind of near the middle of the data. It's not always exactly in the middle, but it's often close to the middle. Okay, same kind of problem here, and at least this one's maybe a little easier to get the midpoints. The first one's very easy to do. Halfway between 10 and 20. Halfway between 10 and 20 is 15. So if you can't do that in your head, halfway between 10 and 20, it's 10 plus 20 equals divided by 2, and that's 15. Now, halfway between 21 and 31 isn't so easy, and in fact, it's going to be a decimal, but 21 plus 31 divided by 2, I guess not a decimal, but it's 26. Halfway between 32 and 42 is 37. You see what it's going up by? It's up 11, so the next one has to be 48, 59, and 70. If you can see the pattern earlier, that saves some time. And I can double check the last one. 65 plus 75 divided by 2 is supposed to be 70, and it is. See? So that saved me a little time if I notice if it's always going to go up by the same amount. So if you figure out what is it going up by, last time it was going up by 0.7, now it's going up by 11. So now write the frequencies down. 8 and 11. 4 and 9. 7 and 6. Okay, start multiplying straight across to get the products. 15 times 8 is 120. 26 times 11 is 286. There's a trick for multiplying by 11. 286. 37 times 4, 148. 48 times 9 is 432. 59 times 7 is 413. And since 7 times 6 is 42, you could just do 42 and put a 0 on the end of it. But 70 times 6 is 420. Then you always add up the products. I'm going to add them up backwards just because the 420 is still on my screen. 420 plus 413 plus 432 148, 286, and 120. The sum of the products is 1819. You always add up the frequencies. Eight plus 11 plus 4 plus 9 plus 7 plus 6. And just by coincidence, it happens to be 45 again. So the mean is the 1819 divided by 45. And notice if you look at the chart real quick, the middle of the chart's like 42 or 43, so I'm expecting some answer near that. It's probably going to be, oh, it's hard to tell, but it might be a little more, a little less than that. But if I do 1819 divided by 45, I'm expecting somewhere close to 42 or 43, so 40 is a reasonable answer. 40.4. Round to the whole number, so 40. Okay, for these situations, which measure of average, mean, median, or mode should be used? You're interested in the most typical case. Most is definitely mode. The data are categorical, so categorical means they're words. So if you have, like, ask people their favorite color, red, blue, green, and so on, you really can't do a mean for that. The mean, you have to add numbers and divide by how many there are. There's no order to colors, so you couldn't find a median in the middle, but you could actually still do the mode. You can do the mode on categorical data because maybe 10 people like blue and only 5 people like red and so on. So there could be a most for colors or categorical data. The values that would be divided into two approximately equal groups, one group containing the larger and one group containing the smaller. So that should be the median. The median is where you have the lowest one separated from the highest, and you try to grab the one in the middle. Okay, the average person cuts their lawn once a week. So are they when they say that the average person cuts their lawn once a week, are they doing the mean, the median, or the mode? So I guess you would ask people, how often do you cut your lawn? And maybe they say once a week, once a month, once every 2 weeks. That's a good question. Which one would be used here? You could certainly do the mode. Maybe most people say once a week. People are estimating this probably is one thing. So it would be hard to do the mean because they're just making up numbers. But this is a good one. You could probably do any of these three and get an answer, but they want to know which one would be the best one to do. Was probably used. I would say it was probably the mode, just because a lot of people do it the same. Everybody cuts their grass probably once a week. And I'm just getting many people to tell me that. And maybe there's people know exactly, oh, I do it every 5 days or I do it every 10 days. So maybe some people are more exact than others, but the ones that are really exact are probably not very often happening. So once a week sounds like the most typical thing when if you're in like the summertime and it's raining often. Okay, but I was kind of guessing on that one. But yeah, that one was the mode, just because you're probably going to get a lot of people saying the same thing, is why I went with that one. Okay, so section 11.3 had 11 problems, and some of them were short answer, like 1 was a short answer, and 9, was that one short answer too? No, but 10 and 11 were. 1, 10, and 11 were just quick short answer, and then 2 through 9 were calculating. And they had 4 examples, all similar, 2 through 5, and then 6 through 9 were kind of similar too. Or maybe it was 2 through 6 and 7 through 9. Okay, we're done with section 11.3, the measures of average. So here in a second, we're going to do measures of variation, which is a similar concept, just you're doing some different calculations. So this will be the 5th. We've done 5. This is our 5th video already for this unit. This is the 5th video of unit 4. So let's do a 5th magic word. And I think I remember the other 4, so let's go with the month of January. The month of January will be the 5th magic word. So send that one to me. Okay, variation. There's 3 common ways to measure variation. And then sometimes they add a 4th one like mid-range, but the measures of center are mean, median, and mode generally. Those are the 3 most common ones by far. In fact, notice on that last problem, they only asked about mean, median, or mode. They didn't even ask about mid-range. So for section 11.4, oops. Section 11.4 is the last new section we learned in this book. And the concept is variation. How do things vary? Another word for it is spread. How does it spread out? How does your data spread out? There's 3 very common measures of spread. The first one's called range, which can be easily confused with mid-range. It's different than mid-range. Mid-range is when you average the highest and the lowest. Range, you just simply do maximum minus minimum. Highest minus lowest. You don't divide by 2. So the other one you add and divide by 2. This one you just subtract. Then there's variance, which is a 5-step process. So it turns out none of the steps are all that hard, but there's 5 steps that have to go through each time. And then finally, there's a last one called standard deviation. It's really the 6th step of the process, because after you get the variance answer, you do the square root of the variance. It's an easy step to do at the end, but if you can't get the variance right, you're never going to get the standard deviation. Okay, which data set would you expect to have the greater standard deviation? Standard deviation, you can just think of it as spread. So it kind of is how are you spread out from the middle? So notice in the first data set, it's 12, 15, 13, 10, 16, 13, 12, 13. They're all numbers in the teens. So maybe the middle's about 15, or maybe it's less than that, but somewhere in the middle of the teens. Most of these first data set numbers are not very far from the middle. They're all pretty close to the teens. But look at data set 2, 5, 26, 31, 2, 10, 25, 6, and 33. So the middle between about 2 and 30 is maybe 20-ish or upper teens. But a lot of these numbers are very far away from that. Every time a number is far from the middle, it makes the standard deviation greater. So definitely data set 2 is going to be more spread out and have a greater standard deviation, because the data set 1 are kind of compacted near the middle. They're all in the teens, while data set 2 spreads out into the 20s and the 30s and the single-digit numbers. So sometimes you can't tell by looking at them, but this was an easy one to be able to tell that the first data set is more compact and the second one is definitely more spread out. Okay, same question, except now it's, instead of giving me numbers, they're giving me scenarios. The amount of time spent studying per week for a PhD student in math at Ohio State University. The amount of time studying per week for all students at Ohio State. So PhD students are probably not only putting a lot of time into their studying, but you don't get that far along unless you're really serious about this. So you're not going to get people that study very little. If they don't study much, they're going to fail and waste their time and money. So PhD students are already hardworking and dedicated, and not that other students aren't, but they're most likely to be more dedicated and put a lot of time in. But the more important thing is that means they're going to all be pretty close to each other. When you get students in general, they're going to be really hardworking ones that study a lot. Maybe there's even some general students that might study more than PhD students. I'm not trying to say that every PhD student is harder working than every non-PhD student. There's going to be some normal students that are not PhD students. They're just normal students, and they might study a whole lot. They might study more than PhD students. But there's also the ones that don't really put much time into it. They're just at college for the experience and the fun times, and a lot of them end up failing and dropping out of school. But so that's my point, is data set 2 is going to have a much wider spread of data. There's going to be a lot of people that study a little, there's going to be a lot of people that study a lot, and there's going to be people all the way in between. Whereas the PhD students, there's going to be mostly ones that study a lot. There's probably still some lazy ones that don't do much, but it's certainly more common among normal students than among the ones that have made it that far. So I would say data set 2 definitely has a larger standard deviation because you're going to get more of the low, middle, and high amounts than you would with PhD students. Okay, so the range is blank emails. Range is the easiest measure of spread. It's simply the highest minus the lowest, and they're literally sitting next to each other because the data is mixed up here. So sometimes you might have to search for the highest and the lowest, but here they were easy to find. Highest minus lowest, that's the range every time. It's the easiest calculation to do. 61 minus 3 is 58. Okay, variance, there's 9 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. They don't have to be in order to do any of these calculations. It can be helpful if they are in order, but... Okay, problem number 3. I'm just going to take them in the order they come. So the first step of variance, step 1, you find the mean, which we've been doing since junior high. So add them up in any order. I'm just adding them up in the order they come. And divide by how many there are. There's 9. Okay, that's an issue. It's always nice if they could come out exactly, so this is going to be a problem with it being 15.111 repeating. Because if you round this to 15 or 15.1, then it can make the answer off a little bit, unfortunately. Okay. So that normally that's not bad if it comes out nicely, but unfortunately it came out real messy. Okay, step 2, you take each number, which I just call x, because as I do a new problem, I don't know what I'm going to get. Each number x minus the mean. Because the mean is so messy, I'm going to do step 2 and 3 at the same time. Because the step 3 is you take each number minus the mean that you just did in step 2, and you do one more step and you square them. So my first number was 61, and the mean is 15.1 repeating. See right here. In fact, what I'm going to do is I'm going to store this in memory. Memory store. So that way I can do 61 minus memory recall. See, you don't want to round this, and it's really messy to not work with the whole thing. Or if I want to work with the whole thing, I mean. So this is 45.8 repeating. I'm just going to write it this way on my work, but I'm going to leave all those decimals in the calculator. So now you need to take 45.8 repeating and square it. So what's nice is I have it on my screen. I can just hit the squared button right now. 2105. And now this is an issue too. I'm going to round to 4 decimals, 7901. Every time you round, though, it can make the answer off a little bit. They definitely should have started with an easier problem than this. Now, one thing that helps is I have 2 3s and 2 7s. Anytime there's a repeat, that helps because then I only have to do it once. So there's 2 3s. The first one would be 13.11, 3 minus 15.111 repeating. 3 minus memory recall is negative 12.1 repeating. So now if I do negative 12.1 repeating and square it, square it. 146.6790. 146.6790. Well, there's a repeat, so the next one has to be the same. So that saves me a little time. I can just rewrite this one. Okay, now we got 5 next. 5 minus 15.1 repeating. 5 minus memory recall. Negative 10.1 repeating. Square it. 102.2345, but there's a 6 after that, so 2346. 2346. This was the negative 10.1 squared. The next number was a 4. So this should end up being negative 11.1 repeating. 4 minus memory recall is negative 11. Square it, 123. And that's due to the fact that the mean is... Oh, no, okay. I thought I had exactly the same answer, but it's different. The decimal part looks similar, but it's different. 123.4568. 123.4568. Okay, we did the 4, the 5. We did, now next we got 28. 28 minus memory recall. 12.8 repeating. So now do this 12.8 repeating squared. 166.1235. 18 is the next one, and then there's 2 7s after that, so at least those repeat. 18 minus memory recall is 2.8 repeating. 2.8 squared, 8.3457. And then the last two are both 7, so whatever one of them is, the other one's going to have the same answer. Seven minus memory recall is negative 8.1 repeating. So there'll be another negative 8.1 repeating down here. But I just have to do it once this way. So square it. 65.7901. And then this will have the exact same answer. Okay, step 4, you sum up all of the squares. Turns out if you add up all of column 2, it always adds a 0. And it's just due to the nature of what the mean is about. The mean is a balancing spot that makes the distances the same, both positively and negatively. So this is why we square all the numbers, because anything squared is positive, and if I add all these positives, it definitely won't add up to 0. But this is such a crazy, I don't know if I can get this where you can see it. crazy decimals to work with. 2105.7901 plus 146.6790. And then I have another one of those, 6790, 102.2346, 123.4568, plus 166.1235, 8.3457, and two different 65.7901s. The sum is 2930.8889. Okay, the fifth and final step for variance is you take this sum and you divide by what they call n minus 1. N is how many numbers we started with. We started with 9 numbers. That's called a sample size. N is 9. Okay, so I was just making sure that there's actually 2 ways this problem can end. Usually it's n minus 1, but sometimes there's another one that you divide by 9, but that's when you have the whole population. So I'm going to take this 2930 number and divide by 8. You always divide by 1 less than you divided the mean by. So divide this by 8, and this is the variance. Round to 2 decimal places. So 336.36. Okay, so it could be all the rounding I was doing is an issue. So I'm not sure how we would do this with such messy numbers. Oh, wait a minute, I thought it said 2 decimals. Oh, I misread it. Yeah, okay. It says round the variance to 1 decimal and the standard deviation to 2. I thought they said both 2. So we did it right. See, 336.4. If I would have read that properly, I would have had the answer right. So 366. Did I have a... Oh, I did write it down wrong too. It was 366.4. So yeah, I made 2 mistakes. I didn't read it right, and then I put 2 3s instead of 2 6s. But once you get this right, and if I would have typed it right, square root, oh no, okay, let's do it this way. If I would have typed 366.4, if I would have wrote that down right, then square rooting, this is the easy thing, is that the standard deviation is very easy. And this one they want to 2 decimals, so 19.14. Okay, this will be a lot better. There's only 1, 2, 3, 4, 5 numbers first of all. And anytime you divide by 5, it's never a messy decimal. They should have done this on the first problem actually. Okay, so this one will be a lot better than number 3. So the mean is easy. Actually, we got to do the range first. Sorry, range is easy. Highest minus lowest, and they keep putting them right next to each other, I guess, to help you out to find them. So the highest number is 340 minus the lowest. That's the range. Range is highest minus lowest. That's a very easy calculation every time if you can remember how it's done. 265. Okay, this will be better than this big mess right here. So now on number 4, we're doing variance. Same 5 steps. Step 1, you find the mean. And there's 5 numbers in the original problem, so that's called n equals 5. The mean's going to be something divided by 5 because there's 5 numbers here. So 340 plus 75 plus 123 plus 259 plus 151 divided by 5. 948 divided by 5. And even though it's a decimal, it's not a big messy repeating decimal like the last one. So this is a lot more doable. 189.6. Okay, step 2 is you take each of the given numbers I call x and subtract the mean. And I actually like to do step 2 and 3 together even if the numbers aren't messy, because it saves time in the calculator. Okay, the first number was 340. So we're going to do 340 minus this 189.6. 340 minus 189.6 is 150.4. See, you can do all of step 2 first and go all the way down and do all 5 of these, then come back and do step 3. But then the problem is you're going to have to retype the answers that you got when you go to square them. Since I want to square 150.4 as step 3, it's sitting on the screen right now. I can just hit the squared button and it goes so quickly I don't have to come back and retype it later. 22,620.16. The next number is 75. 75 minus 189.6. 75 minus 189.6 is negative 114.6. So now do negative 114.6 squared by just hitting the squared button right away. Positive 13,133.16. Okay, the next number is 123. 123 minus 189.6 is negative 66.6. So square that. Positive 4435.56. 2 more to go. 259. 259 minus 189.6. 259 minus 189.6 is 69.4. Squared 4816.36. 4816.36. Okay, last one is 151. 151 minus this 189.6, negative 38.6. Square that. 1489.96. So I'm going to add all these up backwards. Step 4 is the sum of the squares. 1489.96, I got that on the screen still, plus the one above it, 4816. I typed that wrong, 4816. And I lost the other number, I think. Okay, let me start over. Okay, I'd like to put this so I can see it all at the same time. But now you can't see it, but let me move this. So it's 22,620.16 plus 13,133.16 plus 4435.56 plus 4816.36 plus 1489.96. The sum of all the squared numbers is 46495. 46495.2. And remember that we divided the mean by 5 right here. So the fifth step, which is the answer to variance, the variance equals this sum that you just got, 46495.2. And we're going to divide by 4 because we divided this one by 5. It's always one less than however many numbers were given to you. So take this sum and divide by 4. Whoops. There's the variance, 11,623.8. Notice there's no messy rounding on it, so they probably want the whole thing. It does say round the variance to 1 and the standard deviation to 2, but it's exactly, I don't have to round anything, 11,623.8. And then square root that to get the standard deviation. So square root is 107.81. 107.81. So that was much more doable that time. It still took a while, but it's nice if your mean doesn't come out messy, then it's not too bad to do this. And I wanted to show you this too. If I add up the second numbers, what if I add up the step 2 numbers? 150.4 plus 114.6 negative plus 66.6 negative plus 69.4 plus 38.6 negative. Oh, I didn't type that right. I typed 1504 rather than 150.4. Try it again. 150.4 plus 114.6 negative plus 66.6 negative plus 69.4 and plus 38.6 negative. See, that's how I knew I typed it wrong. Is the sum of the second list is always 0 no matter what, because that's what the mean does. The mean balances out the positive and negative distances. The sum of the second column is always 0, which is why we even have a third column. The only reason we have this third column of squaring the numbers is squaring gets rid of negatives. Anything squared is positive. So that's why I like to do the step 2 and step 3 together, because otherwise if you do all the step 2s, then you got to go back and retype them squared, where as soon as I get an answer, if I hit the squared button, then I can instantly get the squared version. Okay, unfortunately, this will be a messy one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least that's better. Divided by 10's okay. This one's crazy big. 2, 4, 6, 8, 10, 12, 14, 15. Here, apparently, they only want the range, so that would be nice. So the biggest number is 33, and the smallest number is 8, so the range is 33 minus 8. That's an easy one, 25. (33 minus 8) on number 7. And then, okay, I'm not sure what they're doing here, but they want the mean of these prices. Mean was taught in the previous section, but they're just reviewing it, I guess. 143 plus 172 plus 248 plus 193 and divide by 4. The mean is 189. Okay, I know what they're doing here. A model that costs $54 is added to the list. What is the mean of all 5 phones now? So what if you go back to the sum? The sum was $756. And what if you add a cheap phone that's only $54? Now divide by 5, because now you have 5 numbers instead of 4. And it makes the mean go down to 162. See, that's what would happen is if you add, just like on test average. If your test average is a 90 after 3 or 4 tests and you take another test and get a 60, then your average is going to drop. How does including the price of the inexpensive phone affect the mean? It made the mean decrease by 27. 189 minus 162 is 27. The average dropped by 27 by adding that cheap phone. Just like your test average can drop if you get a bad one, or it can rise if you get a good one. I don't know why they had this problem in section 11.4, because the mean is actually section 11.3, but that was kind of weird. So there's only 2 problems left, and they're both like 3 and 4, and they both take a long time. And number 6 will be really painful with 15 numbers. But the one good thing about number 5 is there's only 10 numbers here. So the mean's going to come out nicely no matter what happens. 1906 plus 105 plus 655 plus 1891 plus 784 plus 361, 216, 363, 221, and 654. Divided by 10. The mean is exactly 715.6, and I'm going to store it in memory. Okay, range is easy. You do highest minus lowest, and it looks like the first number is the highest. The lowest number is 105. They keep doing that where they put the highest and lowest right next to each other. That helps actually. 1906 minus 105. The range is 2011. Maybe there was a smaller one. Oh, I put plus instead of minus. Okay. See, typo. 1906 minus 105. It's 1801. It's easy to do, but also easy to mess it up slightly. 1801. Okay, so now I found the mean. It was 715.6. So on number 5, I'm going to jump right to my step 2. Each number minus the mean. And then I'm going to at the same time do step 3. Each number minus the mean squared. So the first number is 1906. (1906) minus memory recall, the 715.6 is 1190.4. Whoops. 1190.4. Square that. 1417. 052. It's in the millions actually. 0.16. The next number is 105. 105 minus memory recall is negative 610.6. Square it. 372. 832.36. The next number is 655. 655 minus memory recall is negative 60.6. Square it. 3762, 3672, 3672.36. Okay, 1891. 1891 minus memory recall is 1175.4. So square it. 1381 565.16. 784 minus memory recall is 68.4. Square it. 4678.56. Okay, 361 is the next one. 361 minus the mean is negative 354.6. Square that. 125,741.16. 216 is next. 216 minus memory recall is negative 499.6. Square it. 249,600 0.16. 363 363 minus the average is negative 352.6. Square it. 124,326. 0.76. Two more to go. 221. 221 minus the average. Negative 494.6. Square it. 244,629. 0.16. Last one is 654. 654 point, no, not point. 654 minus the average. Negative 61.6. Square it. 3794. 0.56. Okay, so at least the decimals weren't crazy, but it still took forever. So add all this up. I'm going to do the bottom up, 3794 plus the 244,629.16 plus 124,326.36 plus 249,600.16 plus 125,741.16 plus 4678.56 plus 1381565.16 plus 3672.36 plus 372832.36 and 1417052.16. Hopefully I didn't misread any of mine. So that's what the sum is. Since there were 10 original numbers, we're going to divide this by 9 to get the variance. And if they still want one decimal, Yes. 436. 432. 0.4. And then square root it. The standard deviation is always the square root of the variance. 660.63. So standard deviation is easy. If you get the variance right, you just square root it, and that's easy. But with crazy numbers, the only one that's really nice is number 4, because you only have 5 things to do, and whenever you add them up and divide by 5, it comes out nicely. But 3 was really a mess with a messy decimal average, and 6 might end up being the same thing. I'm not going to do the whole number 6 because we're getting close to the end of the time here anyway, but let me just see what the average comes out to. I'm adding every number up. There's 15 of them here. So yeah, this could be a bad one too. So 6 is just like 3. It's going to take a while. At least all the numbers are single digit numbers, so the subtractions won't be too crazy. But you'd have to do 8 minus this decimal, and then 6 minus this decimal, and 5 minus this decimal, and square them all. But definitely store that one in memory and do it as you go. That way you don't have to retype the average every time. But problems 3, 4, 5, and 6, they're all the same. They want the range, the variance, the standard deviation. In fact, the range is easy. It's 10 minus 0, which is 10. 10 minus 0 is definitely the range. That's easy. And if you get the variance right or wrong, at least if you get it wrong, you could just take the square root of 11.1 and get the standard deviation right. So if you don't want to go through 20 minutes of messy decimals, then just maybe get the variance wrong and square root it. 3.33 is the standard deviation. So at least that's easy. So the only thing I'm missing is variance, and maybe you don't mind missing a few points, but otherwise plow through it if you want to get that right. So there is the end of learning new material. And we covered sections 11.3 and 11.3 and 11.4. And we have 5 magic words so far. There'll be a 6th one when we do the review. So that's it for video number 5.